Hi everyone, this is my 217 physics submission for the space racing game. So once you load up the game, this is what you'll be greeted with. This is kind of the scene, as I'm sure you've guessed. The metal cube's the player. I'll just go over some controls quickly before I actually demonstrate all the different features. So to look left, it's the left arrow key. To look right, it's the right arrow key. To accelerate forwards, it's the up arrow. And to accelerate backwards, it's the down arrow. To change cameras, this is like the default camera, so to change it from this to a bird's eye view, it would be pressing H. Then you're here. Obviously, I'll go over what all these obstacles are a little bit later on. And then if you want to go back to the third person kind of over the shoulder view, it's G. So I'll just show you the acceleration first of all. There aren't any colliders on the skybox, so you'll see me go through them, but I'll come back, obviously. So you can turn, like I said, the maximum is 30. There you go, it's capped. And then you accelerate back down towards 0. It doesn't completely stop, the obstacle doesn't. That's deliberate for the simple reason I wanted to make sure that it kind of resembled space in how you're always moving unless there's an opposing force. It's not fully realistic, but I'll kind of explain later what space kind of physics actually are and kind of how I'd simulate it and why I haven't done that. So yeah, you've just saw me accelerate backwards as well. Again, the cap's minus 30. There you go, you go back down to 0, and then I'll go back into the map for you guys, just so you can see what the objects are like. So, the green kind of planets, these are speed planets, so whenever you collide into them, you'll be sent to the max acceleration, and then you'll slowly go back down to 0, or close to 0. And then all the lava-looking planets, those are asteroids, so when you collide into those, you will then bounce back off at the same angle that you came in, at kind of the negative acceleration, so the opposite, so you'll be moving backwards. So I'll just demonstrate that to you. So there you go, max 30, go back down to 0. I didn't want to delete the speed planets just so you could kind of keep kind of hitting them and testing things instead of hitting it once and then they get deleted. I thought that'd be a bit boring. I'll also collide into one of these just so you can prove, or just so I can show that they work. There you go, you rebound off. I'll show you that again. There you go, and then you bounce back off, and I'll show you that you can also go into them backwards to also kind of move forwards, I guess. There you go, and then you rebound forward as well. So that's kind of just a basic demo of everything that I've done. So what I'll do now is go into a bit more depth on kind of how all the physics works. So I think the first thing to go over is my spaceship movement and acceleration and deceleration. So if you look on your screens, you can see the semi-implicit Euler method, which is what I used. I'll quickly run over it, but basically, obviously, you work out acceleration by the force divided by the weight of the object, and then you work out current velocity by the last known velocity, and then add the current acceleration, which is being multiplied by the time. And then to work out your current position, you take the current velocity, multiply it by time, and then add that value onto the last known position. So obviously, acceleration, when it's increasing, obviously it increases exponentially with time, or the velocity increases exponentially with time. And then as acceleration is decreasing, as time goes on, the velocity kind of stops increasing. And in terms of the way movement works on Earth, obviously this is represented by the car. The green arrow represents motion and movement going forwards, and then obviously you have the opposing force represented by the pink arrow, which is friction. In space, there isn't any frictional air resistance, which means that if you stop accelerating, the last known acceleration speed would be what you'd keep moving at until there was an opposing force, which I didn't want to include for my game because if I was flying around at 30 units, it would be too hard to control. So I thought it would make more sense to include some sort of friction, and then when you reach 0 or when you reach close to 0, you're kind of slowly moving forward to still simulate that in space you're not stopping. So yeah. So I think one area of my game that could be improved quite drastically is the collision detection system that I'm using. Currently I'm using box colliders and I'm using a nested for loop to check if an object is colliding with any other object in the scene, which has obviously a big O notation of ON squared. Because I've only got 4 or 5 objects in the scene currently that have colliders on them, it's not too bad in terms of efficiency, but say if I was to have 30 or 40 objects, the amount of time and computational power that will be needed to calculate if anything's colliding is ridiculous. So that's kind of something that I would definitely change. When I've been looking and researching into techniques, one that came up was dynamic bounding volume trees. And the way that that works is by using a recursive style. So if you look at the images that are on your screen, the top diagram that I made basically kind of represents how the system would work in kind of a 2D game space. So basically you'd have one outer volume, which we've labelled A in this case, and then you'd subdivide that up. So in here we've labelled them B and C. And then because inside B there's 4 game objects, we can basically break that down a lot more. So we've then added 2 more sub-volumes, or child bounding volumes to that. Whereas because C only has 2 objects in it, we don't need to. And then if you look in the image below, you can see that I've represented in a hierarchy tree. And basically because of it being represented in a hierarchy tree, it makes it very efficient in terms of checking collisions. Because if you think about it, if you were checking whether an object in the bounding volume B was colliding with one inside C, if B and C weren't touching, as in the outer bounding volumes, then it means that the child nodes inside those wouldn't be touching either. And because of that, you've just disregarded, and you can basically not check a load of child nodes. And basically, because of the way that's working, you can basically have a big O notation that's logarithmic, which is obviously really efficient, and I think will be really good to try and get in the game. With me previously mentioning about only using cube colliders as well, I think another thing would be quite good to try and add a sphere collider or a ball collider, just for the simple reason, obviously, some of my objects are planets, which are spheres, and I think having a collider that's better suited to them, I think would be a lot better, especially for the things like the asteroids, where the accuracy of what angle you hit it at is quite important. And obviously on your screens now you can see kind of how the collision detection would work, where what you do is you take the radius of kind of 2 sphere colliders, and then if the distance between them is greater than the 2 radiuses put together, then obviously they're not colliding. However, if the distance is less than the 2 radiuses put together, then obviously they're going to be colliding. As well as changing the collision detection, one of the other things that I'd want to change is how the spaceship actually interacts with the asteroids. Currently the way it works is what angle the spaceship goes in at, it comes out at after hitting it at the same speed, which is somewhat accurate, but if you look at the diagram that's on your screen now, the way that it's simulated and the way that it's supposed to work is you go in at an angle, and then you go in at a speed, and then you come out at the same angle and speed, but just in the opposite direction. The way that mine works is I don't come out in the opposite direction yet, which still kind of adds the element of having a hard kind of obstacle to avoid, but at the same time it's not necessarily accurate in terms of physics. Despite the collision detection not being as efficient and kind of well-rounded as I'd like it to be, kind of the fact that it's working, and I've kind of been able to add extra features because of it, like the asteroids and the speed boost, I think works out really well for the gameplay and made it slightly more interesting. And the fact that I've been able to add accurate movement in for the player, I think is probably the most important part of it. So any references that I've been using throughout the project, I'll link in the description of this video. So thanks for watching.